Hey, what is up, guys? So in today's video I'm going to be going over some practice problems I have for an exam coming up, and it's going to be on pharmacokinetics. So what I got open here is I got Anki and GoodNotes open. So Anki is open on the left and GoodNotes is open on the right, so you can kind of see it if I move this. Yep. So I'm going to be taking notes on using GoodNotes to show my work for the calculations. So you guys enjoy. So there's kind of a study with me video, so I'm just showing you guys how I work through like more of the math problems using Anki. We got 32 liters per hour for rate constant, and now I'm moving on to, they wanted it in liters, so I need to solve for time. Oh, mixed up the units, so this is actually just clearance. So this is the number for clearance. Now I'm going to solve for K. Using half-life. Alright, now we just need to calculate the volume of distribution. So basically solving for liters. So 2 liters per hour multiplied by so that will, oh wait, not multiply, I meant divided. Okay, so I came down to 923. Okay, they wanted to one decimal place, so 923.5 liters. And the answer is on Anki, 923.5 liters. Alright. It's about the same thing. And we just finished this deck. So moving on, my final workshop. So this is a much harder workshop. It's going to be for pharmacokinetics. It's going to require a lot more work, so I might be a bit slower than usual, guys. So please forgive me for that. We'll get through these cards somehow. So this is more on infusions or IVs, intravenous. So it's a bit more challenging material. So I'll kind of show you guys how I approach problems. So if I really don't know how to solve it and I'm completely blank, I will just see the answer, or I would attempt it a little using GoodNotes and then reveal the answer, but that's just how I would go. I'd kind of fail at first and then learn slowly. So as you can see, I got about 6 new cards left in this deck. I got 5 mistakes. 5 cards I made mistakes on and still need to get correct, and 11 cards that still need to review. So there's a lot more cards in this deck, but intravenous infusions, it's definitely a lot of material, so we'll get through it together. So it says we're on stable state, concentration. Okay, we got VD here. We got some information for VD. Patient weighs 90 kilograms. I think we could work from here. Okay, so let's try and solve for VD. VD is equal to 0.7 liters per kilogram. We can multiply that by 90 kilogram, the patient's weight, in order to solve for the volume. So we got 63 liters here. All right. And the infusion is running at 20 milligrams per hour. Total 20 hours. So steady state is milligrams per liter. So let's try and get a time here. So if the infusion is running for 20 milligrams per hour, let's try and multiply that to 12 hours. See how much milligrams we'll get. Got about 240 milligrams. Milligrams per, just milligrams, okay. I think I'm missing something here. Okay, at this point, I can't seem to solve for much anymore, so I'm going to just reveal the answer, see where I'm getting things wrong. Okay, so it looks like there's a formula for this. So rate of infusion times time first times 12 hours is equal to 240 milligrams. Oh, kind of did that over here for the first part. I just didn't have the final equation for a stable state. Dose times S times F, which is implied over the elimination rate constant times the volume of distribution. And the volume of distribution we kind of solved already over here, and multiply that by time. Okay, I know where I got wrong. I was on the right track though. So I'm gonna put this, I need to review this again, even though I got it right before. Okay, so plug and chug question. I'm gonna do this on my calculator to kind of speed things up. So the rate is 50 milligrams per hour. Multiply that. Stable state was not reached. Runs for 7 hours, so we got the dose is 350. Just solve for C1 over here. I have a calculator on my hand right now, so just entering it on there. So dose is 350. A stable state wasn't reached, so assume it's 1 for S, 1 for F. Clearance is equal to, what is clearance? Did they give me clearance? Yeah. 10 liters per hour multiplied by time, so three hours. Wait, I think for capital T, I think that's the total number of hours, so I'm going to stick with 7 for that. And then for the final part, 1 minus e to the negative 0.216 times 7. That comes out to about 3.898. 3.898. And then for C2, it's about the same information, but we're going to be multiplying 3.898 by e to the negative 0.216 multiplied by time. So I think this includes the 3 hours after stopping. Multiply. So I'm just going to enter in my calculator now. Multiply by e to the negative 16 times 3. So I came out to about, I'll show you guys right here, 2.04. Okay, let's see how this comes. Oh, came out right. All right, that's what I'm talking about. Oh, but we did forget the units. So this concentration's milligrams per liter. Awesome. Here we guys. Teamwork. Okay, let's make some more. Loading dose of 1 gram is given to a patient on distribution of 50 liters. Patient's K is 0.11. Plasma concentration in milligrams per liter. 8 hours after loading dose. One gram. Okay, for this one, I think I need the equation for it, so yeah, I definitely need the equation for it. So for concentration 1, I would take the loading dose and divided that by the volume of distribution, and then the loading dose would move on to first solving the second concentration, and then multiply that by E. Okay, this was one of the mistakes I made last time I was reviewing this deck. Also, continue on. Alright, I don't remember doing the first problem, but we'll see if we can solve it. Stopped for 5 hours. Okay. Oh, actually, I did do this question. K times. Okay. Stopped for 5 hours. Huh. So in the original problem, it was stopped. Was it stopped? It wasn't. Oh, I think this is the same thing, but I think this is how it's gonna look. 2.6 milligrams per liter. We multiply this by E to the negative 0.123 times time. This time we want it in 5 hours. We've got the steady state concentration. Okay, let's see if this is gonna work. 1, 2, 3 times 5. Okay, so I came out to 1.4 milligrams per liter, and the answer here is, oh, wow, that worked out. Looks like everything you learn just kind of goes to everything. What you learn in one problem can apply to more problems. That's math. Okay, we got a rate already. Okay, this is very similar to that last one. Okay. Can do this. Patient weighs 90 kilograms. Okay, let's solve for volume of distribution first. Here's per kilogram. liters. Okay, I think I remember this one. This one is the one where the formula is the rate over the volume of distribution. Liters. So that comes out to about 0.317. Okay. If the infusion runs for 12 hours. Let's try this. So, 1, 2, 3 times 12 hours. Okay, let's see if this worked. Round 10, there's one decimal place, so that's about 0.1 milligrams per liter. Let's see if that's right. And it's wrong. Okay, where did we go wrong? We did not solve for dose. Okay. Man, we used the wrong formula for this one. Okay, can't get them all. So we should have done rate times time, 20 times 12 hours. That's fine. And then for steady state, we solve for the dose, and then K times distribution over time. Okay. PD of 50 liters. Okay. They said I want plasma concentration. Milligrams per liter. I'm not sure what to do for here. Okay. It's getting challenging. Okay, we got continuous infusion running. Alright, we got formulas. That's great. Let's use our formulas. Let's go dose. 30 milligrams per hour. After 10 hours. 10 hours, our dose will be 300 milligrams. Okay, after we know our dose, we can solve for C1. So we can plug in our loading dose here. Times S times F. And the volume of distribution is 30 liters. That's my E to the negative 0.9 multiplied by the time, which is 10 hours. We add that to the dose we solved previously, so that's 300 milligrams times 1 times 1. All this over the clearance, which is 15 times time, 10 hours. Multiply it by this one. I'm not sure how to paste here. And then multiply it by this one. Okay, so I'm just gonna plug that into my calculator real quick. $300 over 15 times 10 times E plus Alright, so my answer for C1 is 6.9 milligrams per liter. Let's see if this is right. Oh no, it's wrong. Where did we go wrong? Okay, we got 500. We solved for 300. That's correct. 500 over 30. So 99 times 10 plus 1 minus, oops, it was supposed to be over here, 1 minus e to the negative blah 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 for that one. Okay, my bad. It's a bit of laziness on my part. Continuous infusion. It's running at a rate of 20 milligrams per hour. Okay, I'm gonna try and solve this by hand to speed up time. Just because it's almost midnight. Yep, it's a late night study session, guys. I'm trying to train myself as if the exam is tomorrow. Let's see if this will work. So we got 63 liters here. My VD, I solved for 63 liters. So after you got that, so the infusion runs for 12 hours. So let's solve for the dose. 20 milligrams per hour times 12 hours. $240 milligrams total. Alright, so let's solve for CSS. So we got the dose, 240 milligrams. All of this over our VD, so 63 liters. We got a K. We got 0.123. And the time. Just put the time over here, 12 hours. Okay, so we got 240. I'm just gonna solve this on my calculator now, guys. 1, 2, 3. That comes out to about 2.6 milligrams per liter. Now let's see. We got that correct. All right. This was a problem I got wrong before, but now it feels good to get it right. Keep learning. Next page. $50 liters. I don't think I've done this problem yet. So what is the plasma concentration? Okay, so 1 gram is equal to 1,000 milligrams. So there's about 1,000 milligrams. Loading dose, what are we solving for? We want the CP, plasma concentration, so we get the loading dose, 1,000 milligrams. We don't want it in milligrams per liter. Over 8 hours. Okay. Okay. Let's try this. Over 0.111. Plasma concentration. Our V is 50 liters. $1,000 times 8 divided by 0.111 times 50. Oh, that is a really high number. That's not gonna work. Okay, I'm not sure how to do this. Okay. 1,000 milligrams divided by 50 liters. Okay, that's how you solve for that. once you get concentration 1. Okay. Okay, that makes sense. We'll get there. This is a very tedious one, so I'm gonna kind of skip this. Okay. There's a new one. Okay, I might need to start fresh for this one. Let's go. So what are we looking for? We're looking for the steady state trough. I believe that's the Cmin. But before we can solve for the Cmin, the Cmin, same thing. We must first find our Cmax. Cmax is equal to okay, there's not enough room for this. Okay, what are we gonna do? Can we move it? Please tell me we can move it. Yes, we can. That's great. Let's start a new page. Can we move it over there? Nope. Let's just move it over here. So time is infused over 2 hours. Actually, this video is coming too long, so I'm just gonna end it here. Hope you guys enjoyed this video. Hope it helps you if you are studying for anything. This is kind of a study with me video, so it was very challenging. You're kind of watching me learn here as if my exam is tomorrow. So thanks for learning with me, guys, and I will see you in the next one.